All right, welcome back. We are going to talk about hyperbolas now. Okay, so here's the problem. Consider the hyperbola below. Okay, and the first thing to do is to put this thing into standard form so we can answer some of these questions. All right, so what do we have? I'm going to anticipate the fact that I've got a negative sign here. So I'm going to go ahead and write it this way. Negative 100 x minus 7 squared plus 64 y plus 2 squared is equal to negative 6,400. Now, the first thing we're going to do is we're going to divide everybody by negative 6,400. All right. So this is going to be a 1. That's important. The right-hand side always has to be a 1 when we're talking about standard form for conic sections. 64s are going to cancel, but the negative, so we're going to have negative y plus 2 squared over 100. Okay. Hundreds are going to cancel, so we have negatives are going to cancel, so we're going to have x minus 7 squared over 64. Okay, that is our standard form, right, for an ellipse. Okay. Now, same thing with every other conic section, right? Is we have the center. So center is 7, negative 2. Okay, same thing. X minus h, y minus k. Okay, same thing as every time. All right. Vertices. Okay, now vertices you have to choose like which one is going to be the real vertex and which one's not the vertex. Since the x part is positive, this hyperbola is going to open side to side like this. If the y one were positive, it would open up and down. Okay, but we have x1 is positive, so it opens side to side. Our vertices are on the x line here. Okay, so what we're going to do is we're going to say set y equal to negative 2. All right, so we're going to have x minus 7 squared over 64 is equal to 1. Same deal with this is called method of intercepts, by the way. It was called that when we did it for the ellipse too. Okay. Multiply both sides by 64, so we have y minus 7 squared is equal to 64. Y minus 7 is equal to square root plus or minus 8. So we have x is equal to 7 plus or minus 8. So 7 plus 8 would be 15. 7 minus 8 would be negative 1. What was y? Y was negative 2. Okay. So remember, y is equal to negative 2. So where are my vertices? Well, they're at negative 1, negative 2, and 15, negative 2. Okay. Again, notice my center, negative 2. Okay, and the center was 7, so this is plus or minus 8 from the center. Okay, so I need to do the y ones at this point anyway, just for the sake of being able to draw my little box for this to work. So we're going to set x equal to 7, and we're going to take the positive. We're not going to worry about the negative part here. So we have y plus 2 squared over 100. If x is 7, that's cell 0 equals 1. Again, method of intercepts. Method of intercepts equals 100. Y plus 2 is equal to plus or minus 10, right? Square root of both sides. Okay. And we're going to have y is equal to negative 2 plus or minus 10. So negative 2 plus 10, negative 2 minus 10. So that's going to be 8 or negative 12. No, yes, 8 or negative 12. All right? Yeah. Yeah. Okay, so what was x? X was 7. So we have 7, 8, 7, negative 12. Okay, next one up. So there's our vertices. This is what I really wanted to answer. Okay, great. Foci. Okay. Foci for a hyperbola is c squared is equal to a squared d plus b squared. The c is going to be plus or minus that from the center. Okay, and again, along the x part because the hyperbola opens from side to side. Okay, so what are we looking at here? We're looking at 100 plus 64. So c squared is equal to 100 plus 64. C squared is equal to 164. And does 4 go into 164? I think it does. I think we have 41. So this is 4 times 41 here. So the square root of 4 times 41 is equal to square root of 4 times the square root of 41. This is plus or minus 2 root 41. Okay, from the center. Where's the center? Center was 7, negative 2. Okay, so my points for my vertices, right, or my foci rather, sorry, vertices, foci. The points for my foci, okay, are going to be 7 plus 2 root 41, negative 2, and 7 minus 2 root 41, negative 2. Okay? All right. Next, what are the equations of the asymptotes? Right, at the point you say, wow, what jerk wrote this problem? So what we're looking for here, right, is we have a rise and we have a run. So let me start graphing this thing so you can see what's going on here. Okay. We have 7, negative 2, so we're going to be dealing with like quadrant 1, quadrant 4. So 1, 2, 3, 4, 5, 6, 7, 1, 2. 7, negative 2. That's my center. All right. We could talk about our vertices. So what is this going to be? It's negative 1, negative 2. Okay. And what was it, 15? So that was 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So we're going to be doing something, go ahead, we'll do it this way. So we're going to be dealing with something like this, right? Okay, pretend that goes to the vertice. I don't really know how steep these are going to be. Okay, that's where these guys come in. Okay, you'll notice I went about 8 away from my center. I also need to go about 10. Right, square root of 100 is 10. So what's going to happen here? Okay, is from this point right here, okay, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then we're going to go down 10. So 1, 2, 1, 3, okay, 4, 5, 6, 7, 5. There we go. There. I think we're 12 down here. Okay. So we have to do the same thing over here. So we're going to be up here and down here. Oops, sorry, didn't quite make it. All right. So here's the box. Okay. Here's my box. Pretend that's straight. Okay, actually just pretend that this makes a box, a square. And the hyperbola is going to pretty much follow. That's terrible. I can ask you to pretend that those are straight, but this was awful. We're going to draw a diagonal from the center here. Okay. These are supposed to be lines, by the way. And my hyperbola is going to hug those, is going to hug these asymptotes. So really, it should look something more like this. Okay. All right, that's what it should look like. And I'd like to know, what are the equations of these lines? Okay. Well, one thing we're going to do is we are simply going to count on our fingers and say, what's the slope? Isn't that the rise over the run? Isn't that what you guys get drilled into your heads in elementary, sorry, middle school? So what's my rise? The rise is 10. What's the run? That's 8. So the rise over the run, that is 10/8. Let's cast out a 2, so that's going to be 5/4. Plus or minus, because the rise over the run in this direction is going to be, a rise of -10, right? Well, there's a fall of 10, and then the run is still the same distance. Okay, so here's my slope. Notice, both of the asymptotes go through the center. Okay, both of the asymptotes go through the point 7, -2. Okay, so in order to get my slopes, or in order to get my equations of these lines, right, we're going to do point slope form. Okay, so remember, this is point slope form. The easiest model we have in math is a line. And there's a lot of times where you have some data and they say, well, make a model, and you fit a line to this thing. Knowing this point slope form is going to be real useful for a lot of science classes, your calculus classes. It's just a real helpful thing to know. So I know when we pull it out, you're like, how are we expected to memorize that? Like, you are. Okay. So we try to reinforce it, but not as well as we should. Okay. So here we go. We have y minus -2. Do you mind if I hold the m as m for just now? And this is x minus 7. Okay. So this is going to be y is equal to mx minus 7m plus 2. All right. So here we go. Case 1, m equals 5/4. Y is equal to 5/4 x minus 7 times 5/4 plus, can I say 8/4? Is that 2? Somebody up for a moment. All right, hopefully that'll help. Okay, I just locked her in the bedroom, that's all. Minus 35/4, right? 7 times 5, plus 8/4, so that is y is equal to 5/4 x. What is that? 35 minus 8 is going to be like 27 or something, so minus 27/4. Sure, that's a delightful looking line. Case 2, m is equal to -5/4. Okay, so we have y is equal to -5/4 x minus 7 times -5/4 plus 8/4. Okay, so I just set up the problem first so I can plug in my points. Y is equal to -5/4. We have plus 35/4 plus 8/4, so that's 5 as an x. 5/4 x. Add that together, right? We get should be like 43/4. That's my other line. Okay, so that's how you get with the asymptotes. I think the one on your final exam is not quite so involved. So you still have to know how to do this, but I tried to make the arithmetic easier on that because this problem's already long. And I think the last thing we had to do here was graph it, and I think we've already done that. Right there, we're done. Okay, so that's how you deal with a hyperbola. That's how you put it together. That's all the possible things I could ask you. All right, so I won't ask all of them. It's already a long problem, but that's a whole demonstration. All right, so I will see you in the next one for the parabola. Okay, so. And